Salam all. So today's lecture we are going to learn few more syntax and some of the syntax I think that you guys already know before because I have been using it since in the beginning of the class. So in this particular slides, in this particular section, we are going to learn about the array, especially about the arrays. This is the array, which is the one and the two-dimensional arrays. And after that we have another session only for the stack. Okay, so I'm going to have two different videos for these two sections. Okay, okay, let's start. We are not going to touch this one at the moment because this is just another syntax for the EQU. But I just want to tell just very brief for the EQU syntax is normally it's just like the equate. Equate means equal to something. So for example here, when you want to use equate, right, this is your label. You're going to equate it to these particular locations of the memory. This is just like something that you want to declare or you want to initialize something. Okay, so this is going to use equate. So once after you use this equate means that this BACR is always related to this one, it's always pointing to this one. So it's just giving you another thing, a way for you to just make something that is similar to it. Okay, so it's just an EQU. This is the example here. If you want to change something, you just can change at the beginning of the process or beginning of the codes, rather than if you put your code like 1000 lines, so you just need to change only one. Okay, that's for the EQU. Okay, this is the one that we are going to concentrate today. The first one is the syntax for DC. I have been taught you guys so many times about the DC syntax. If you can remember the syntax here, let's go and check. Okay, the DC is the one that we want to put something at the memory location. For example, we are going to put the value at origin, maybe at 3000 area. Then you have this dc dot byte or w or long word. So this is going to do what? Okay, so define constant, which is a DC, are used to create locations for variables. So this is the define storage. Okay, so define constant is to define the constant at this location, whereas another one today for the new syntax you're going to learn is DS. It's just actually going to define a storage, but just a storage means just a place for it, does not put anything inside there, because the one that you want to put a value is actually using by DC. For example here, define constant dot byte $sign for a, and then because of bytes here, okay, because of byte here, then you are going to have another one here, because it's byte only two numbers allowed, and then you have BB here. Then you can put another one, this define constant dot w, means that it should be 4 digits. Maybe you can put 19 AA, and then define constant dot long $sign 1 2 3 4 4. Okay, so if you run this one, you can look at the values at the memory over there at 3000. Sorry, not here, 3000. Now you can see the value is inserted. That is at the location starts at 3000. Okay, 3000 is inserted with 4A, and then BB here, and then we have 19 AA, 12, 33, 34, and 45. So this is the numbers. Okay, so this is defined byte. This is the value over here. So you can try again, play with this value. maybe you can just put another value here, define constant dot byte, another one, $sign DA, and then you have maybe define constant dot W long, $sign. If you put only 78AA, let's look what happened. Even though this is long, you only give 4 digits over here. Is there any problem? There's no problem here. You can execute it. So you can look at the values at the memory again. So 4A, BB, 19, AA is still correct. Then you have DA, and then this one is FF. Okay, this one is because of the value here is byte. Byte means that it's taking over the locations of 3004, and then the next instruction is this define constant dot long, and then you understand that for the long and word size, you are not allowed to start at the odd memory location. So it means that it will skip these locations over here, and then you have 00 starts here because of, even though this is define constant dot long, you are given only 4 digits. So for the long size is 32 bits. So you have to put all 00 here, 00 here, 78 and AA. Okay, so that's the reason why it has all this 0 and all this F, which means that this is not written in the system because of the sequence is different. So let's say, for example, if you change it to byte, this one, and you have to change it to only 2 digits. Okay, let's look at the memory again. So 4A, BB, 19, AA, DA, and 78 is over here because byte has no problems to put or insert it at the odd locations, so there shouldn't be a problem. Okay, let's try to run another one. Maybe we just want to have an ASCII values. So define constant dot byte, just put A, or maybe define constant dot word, maybe BEKM. I think let's try to put BEKM, and then we have another one, maybe design.com W utemp. So the difference here, you can see that by using a $sign, this is actually going to be hexa numbers. So I can put a string value. Okay, string is something that a character. So what will happen? Is it going to be A here and then put inside the memory, or BEKM inside to put in the memory? And you have to understand that inside the memory you are allowed only numbers for hexa numbers. So this is not going to be hexa numbers. So let's try to look at the results here. So let's run this one. Okay, and then we're going to look at the memory, because this is the one not inside your program, right? So it should be already there when you execute the file, so it shouldn't be a problem. So now you have 4A, correct, and then you have BB here, you have 19, you have AA, you have DA, you have 78, and then you have 41. This is A is related to 41. Then because of the next one is W, this is not going to be written off. Then you have the BEKM, so this is BEKM. So 42, 45, 4B, and 4D. So this is BEKM. And the last 4 is utemp, U, T, E lowercase, and M. So this value is actually taken from the ASCII table. So let's Google the ASCII table first. Okay, ASCII table character. So this is the ASCII table. So what does it mean in ASCII here? The ASCII is the one that the character that you use on your keyboard. Okay, your keyboard is the one that having the character, the small character, the ABCD, right? So you have to look at this value over here, and for just now we have A capital letter, so you can see that from A is where? A is here. Okay, A is here, and then the hexa numbers related to the character is this value 41. So let's have a look at the value just now. So A is 41. So A is 41 here. And then this is not written. Then there's BEKM, all capital letters. And then we go back to this one, BEKM. Capital letters B is 42. E is 45. K is 4B. And 4D. 42, 45, 4B, and 4D. 42, 45, 4B, and 4D. Then you have UTEM, UTEM. Okay, let's look at UTEM. UT, so 55, 54. E lowercase should be over here, 65. So 55, 54, 65, and M is 4D. So is it correct now? So 55, 54, 65, and 4D. So that is UTEM. So in define constant, you can put a number, or you also can put a string or a character. Then the system will automatically change it to the hex number accordingly using the ASCII table. Alright, so that's for the define constants for the syntax we have been used so far. Then we have the storage, define storage. Okay, for define storage, you're going to just reserve a storage. Means that, for example, that if you are going to put define storage dot byte for 6 times, so means that you're going to save a location in byte size. Okay, save a location in byte size for 6 times. Same goes to this one, save a location in word size for 2 times. It will, if you have all this one, right? For example, here let's try to have a example here. Define constant, define change, define storage 2, and then define storage. So this is, sorry, define storage dot byte 2 times, and then you have define storage dot w for 2 times. Then you have the define storage dot long, maybe for 1 time. Then we are going to run it. Let's look at the results. So at 3000, there's nothing because there's no value, because this is just a define a storage, just not like the define constant just now. We can see the values here according to the values that you put. But over here, what you're going to look at is over here, the locations of the memory. So here right now, okay, let's open up back this one, the view, the memory location. So you can see from 3000 to 3002, 3000, 3001, 3000, 3001 is reserved for define storage dot byte 2 times. And then you have the define words, define storage for words 2 times. So after this, it must be word for 2 times. 1, 2, 3, 4, 1 words. 1, 2, 3, 4, 1 word. So you can see here, it's going to be 3000. Or word, sorry, word is going to be 2, right? Yeah, 2. 1, 4, 4, 16. So 2. So words is going to be here, 1 word here, and another word here is here. So they are being two words. So this is byte, word, and word. So look at the value for the locations here. So the first one is define storage.byte is from 3000 to 3001, and then the next one is 3002 to 2005, 2002 and 2005. So correct, is stored for 2 word size over here. And then you have the last one is define storage.long, long up to 3006 to 2009, 6 to 9. So long should be 4, 1, 2, 3, 4. So this is the long word, only one. And then the next one is nothing. So this is only to define a storage. Okay. So that is the difference on the define storage and define constant. And this command is normally used for the array. Array is a data structure that contains a group of elements, usually of the same size and data type. Same size and data type. Okay. So there are two sections of the array. One, they call it a list. This is a list. A one-dimensional array. This is the one. Two-dimensional array, they call it matrix. So maybe you can Google back. There are 3 films matrix, sort of like this one. It's just like something like the terms that you've been used in the film. So a list is one-dimensional matrix, and the matrix is a two-dimensional matrix. So the difference is like this. It's quite simple. It's quite distinctive, where you can see that when you want to create an array, which is a list, you are going to label it the names of the array over here, and then you are going to use define constant dot byte base. It's up to you. It's a byte or words or long word. Then you're going to put the value here. This is, for example, there are 5 elements inside the cards array. This is the names, array's name. This is the definitions of the array data type. So they are going to be byte size here. So this is all of it. This is all of it. And then you can create another array after that array. This is just one dimensional array, right? You can just create another one here. After that one, you have the other one suits the names of the array. It's up to you what names that you want to put. You can put your name also, no problem. And then it's define constant dot byte 0000. This is the value, and then you also can use as a define storage the value here. This is like it's saving like 5 locations of byte like this. Compared to two-dimensional, you can see here the two-dimensional array matrix is like this, which you can see that this is the name of it, magic square, and then you're going to define the constant dot byte, and you can see that the values are like this, and there's no more definitions or declarations in front of the second row. So this is going to be a two-dimensional matrix. It's two-dimensional, which is a matrix. Okay, this is how to define or create matrix. So both of this method is how to create arrays. Okay, let's move on. Okay, in one-dimensional array, right, you can see that the value is like this. It's a cards like this, for example, just now. So cards and suit are 5 byte one-dimensional array. Okay, one-dimensional array. Each of this array represents one row of 5 value. So this is one row. Okay, one row, 5 values. 5 values. Or they call it elements. Okay, the specific elements. Okay, the specific elements access. Okay, access means you want to read or write this area. They call it access. Access means you want to read or write. Read or write. Okay, if you want to access the specific element in the positions of the array, we are going to use the index. Okay, what is the index? So here in this example, for a 5-element array, for this one, the index has a range of 0 to 4. So the index will be 0 here, index number 1, index number 2, index number 3, and index number 4. So that is the range of the 0 to 4. Okay, that's that call it for 5-element array, the index has a range of 0 to 4. So it means that when I say that access is the meaning of access is actually you want to read or you want to write. Okay, let's look at the example here on the array, how to read and write. So this is actually going to be you are going to access it. They call it access. So this is the meaning of access, read and write. So you're going to use address register indirect, okay, to read and write individual elements of an array. So the operand notation will be like this: the locations and the element that you want to access. So this is base address. Base address means that if you have your, for example, just now cards 1, 2, 3, so you have to know that what is this location, where is this location, then that will be your base address. Then you have the index here, which can be any address or data register, can be anything, but this is going to point the location. If for 3 means you have to find out the location index number 3, 0, 1, 2, 3. So this location, not this one, this is the index location. Okay, let's look at this example here. You have the value, for example here, in this command, you have the origin 2100 and you have another origin is 3100. So you can see that these are two lists declared at two different locations. Okay, one is at 2100 and another one is at 3100, and you can see that the value for the locations of the AA must be starting from here, and the value for 11 is starting from here. This is your for example, this is your command, this is your operation, how to access it. So last time we learned about load effective address. Load effective address, the contents, okay, the array here, the height is the array. Okay, height is this one to A0. Now this is A0 is address register. So load effective address must be put at the address register. So the address for height, okay, the address for height is this location, because this is the base address, right? Okay, so this is going to be 2100, move to A0, and then the index, I'm going to put it somewhere to D0. D0 is the index, now index number 2. Now you can see that you are going to change, or this is going to copy or read from the contents at 2100 at location index number 2, going to be moved to D1. So D1 is going to take care of the contents of heights, okay, A0, D0, index number 2. So this is index 0, index 1, and index 2 will be put to D1. Read and copy to D1. So this command for next command is going to write this value at this command, mean it's going to replace the contents over here. And then the last command is only to validate what is the final value, and then you put it at D3. So let's look at the example in our EZ68K. So right now I'm going to run this one. Okay, 2100, 2100. So you have two locations of your array. So this is AA, 6A, BB, 60, and CC, and you have another one is 3100 at 11, 68, 22, 60, 33 is this one. And then this is the command that we are going to run. Load effective address for height. Height is this value. Height is this array. The value must be coming from the address for the height is going to A0. Okay, A0 now is containing 2100. This one correct. Now index D0, index going to be to D0. D0 is going to take care of this value index defined constant byte 2 just now. So D0 is going to take 2, correct? And then the contents here, A0, this location, and the index number 2. Index number 2 is this one, 0, 1, 2. It should be here. This one must be put at D1. So let's look at D1 over here. Now you can see the contents of the array, index number 2 is being copied to D1. Now this value, this is a constant value, is going to put to the locations. So right now your view just now, the B still be here. There's nothing changing. Yeah, right. There's nothing changed yet. So if I want to put this value, new value to this location, means that it's going to put the location to the address of the array with the index number 2 access the third value here. So this is the one going to be changed from BB to 2D. Let's run this one. Is it correct? So correct, at this location had been changed to 2D, and then the last command is only to send the data back to the D3. This is a validate the value, the contents, what it has to D3. Okay, so that is for the example of a list or a one-dimensional array, which is quite easy. Then we are going to move to the calculations of the effective address of any elements. So now, for all this value, right, for all the contents, all the elements, you can actually get the address of it by using a formula. Okay, in general, to calculate the effective address of any elements in byte, so it's up to the array. It's up to the array. So if the array is defined constant by words or long word, it will depends on that. So effective address of any elements in a byte, word or long word will be based on this formula. So the effective address for any elements will be based on the base address here. Okay, effective address will be on your base address for the array plus the offset. Okay, where offset is equivalent to size times index. Which one that you want to know? This is based on what types of array. For array, it has byte, you have to plus 1, word you have to plus 2, 2, long word you have to put 4. Okay, this is times index. Index is what index, what's the elements that you want to know. Then you can get the base for the array, then you can plus the offset. So the effective address finally is going to be the base plus the size times the index. So let's look at the example. The starting address of word array is 830C. So what is the address of the whose word whose index value is 5? So based on the formula just now, effective address is equivalent to base. Base is given by this value, and the size is going to be size and index, and offset is going to be size and index. Size is what? Size is a word size. Word is going to be 2, and the size okay, is what? Yeah, size is going to be the what just now? Size the element. Sorry, size is a word 2, right? And then the index. Index is the elements of the index, which is 5. So 2 times 5 is 10. This is in hexa. 10 is equivalent to A. So 830C plus A is equivalent to this one. So the address, effective address for a word array index number 5 will be at this location. So this is the address just now, right? So you can see that this is 1, 2, 3, 4, 5. So this is the location starts. Right. Okay, let's move on. Then you have the two-dimensional array. Difference is when you want to define the two-dimensional array, you just only have this one, and then you have how many, that is up to you based on the column and size that you want to have. For this example is 3 times 3. Okay, by matrix in row magic order. So this is without dollar sign, so it means that it's still decimal. So again, this is the value, same goes to hexa, it's the same number. So you can put here like this, the value, this is by column, this is by row numbers. So if you want to put value inside the memory, still the same. The system will automatically save it, but now you have to go for the row and column based on this one. But in terms of the memory location, it will based on like this. 06 will be here, and then 1, 8, 7. It's the same thing like when you put the defined constant just now before, right? But yeah, now the difference is because of this one, the row and column. Okay, because of you had defined like this, it's actually going to be a two-dimensional array, which is the matrix. Okay, let's move on. Again, for the elements that you want to access is going to be the effective address here. Formula is going to be the base address plus the size times bracket row times n columns plus column. So you have to do this one first, right? It's actually going to be here plus column. So let's look at the example of the array here. Okay, now let's look at this one, right? Okay. Example of the programming that we have. So you have the size. This is our origin that you want to do the declaration for the numbers. Then example here is your matrix. Okay, right now if you go to the contents here, this is your array content, and the command for load effective address matrix is this one, which is going to be 5000 to A0. Row is what? Row is going to be 1, D0, and columns. Okay, and columns, this is going to be the command that you want to do the row times column just now. This is the one, mulu. This is mulu, and then you're going to add column, this one to column. So this is the one. Okay, so this command is basically doing these two commands, and then you have the size D0, then that is going to be again times, okay, size times the whole thing. So you're going to times again this one, and then you get this one, D1. Then you can get the effective address for that particular elements. Okay, now based on that one, so A0, okay, A0 is the load effective address just now. For that one, for the case is 5000. So D0 now going to have the matrix for that one going to be saved to D7. The contents of D0 is the matrix going to be accessed. Okay, let's try to have a easy 68K example here. Right, let's look at the results. Okay, one by one. Load effective address of matrix to A0. Then you have this one 5000 because of matrix is located at this 5000. Now move W row to D0, row to D0, D0 now 1. Okay, n columns. Okay, n columns, D0 is equivalent to row times n columns, row times n columns. So you're going to multiply this one, row and columns. Okay, and columns to D0, so this is multiply. Okay, let's run this one. 1 times 3 is equivalent to 3. Then you're going to add to the column. Okay, add to D0 again, column, add to D0, column is equivalent to 2, 2 is going to be add to 3, now it's 5, correct? Now you are going to multiply again the contents here at D0, multiply to the size is equivalent to 1, just do this one, and then you are going to move. Okay, now you have the A0 is this location, right? And then you have D0 is 5, that is the locations that you want to change or to access the matrix. So where is it? So let's look at the result at D7. It has number 3 here. So the elements is at 5, so this one 0, 1, 2, 3, 4, 5. So that is the locations of the two-dimensional array that is going to copy to D7. So that is the location of it, based on this one, and that is based on the formula that we have right now. You want to find out where's the effective address, because you know that in elements, right, elements for one dimensional is very simple because we are going to use the index directly, but because of the two elements, two-dimensional array, so you have to find the effective address for it. Okay, so how to take on that one? So you have to know that this is the contents, this is the value for the base address, and this is the informations that you need to know, because it must have the columns and the row, and then you can finally find out where is the locations from that one. Okay, so that is the case how to access a two-dimensional array. Okay, this is the example that you can just have try to look back at your EasyCCAK, and this can be another example on how to calculate the effective address by given a matrix size. So a 5 times 7 matrix is defined and stored in raw major order. The matrix has a base address of 8300 and is composed of long word. So the size is long word and the base address is 8380, and the matrix is 5 times 7, right? So what is the address of elements of 3 times 5? So you want to find out the elements, right? The elements of 3 times 5. Okay, the elements, this is the one. Let's try to have this one. This. Okay, the same thing here. By using the formula, effective address is 8380. This is the base address. Size is 4 because of the long word here. Okay, this is the one. Long word. Okay, size is what? Size is 4. So where's 4? 4 is this one just now, long word. And then you have the row times n column. Okay, the row, this is the row number 3, element number 3. And then you have, this is the n columns, the whole matrix size. N columns is, this is row and column, right? So this is the column here. And then this is going to 3 times 7 plus 5. Column is the one for the elements here. This is the n columns. We go back to this one just now. Number of columns in the matrix, and this is the column number that you want to find out. Okay, for this case you want to find out this one, and then the columns for the matrix that you want to have is this one, 5, row and column, right? So n column will be 7 here, and then you are going to do the mathematics for the hexa numbers. And finally, the effective address for this particular elements is actually at 8448. Okay, so that's a bit different on that, because for the array, for two-dimensional array, it has more variables that you need to insert. But this is going to be the same thing like the list. You need to find out where is the locations of the address of the elements for the array. Okay, that's all for the arrays chapter. So we're going to look at the second chapter on the stack. Thank you very much.